Yeah. Yeah, I want to talk about an open functional safety lifecycle workflow, utilizing many different tools, of course, all open source tools as far as possible. We will come to 2 points where it's very difficult, but nevertheless, it's still manageable in order to build up really a product development workflow based on open source tools, which can, and we will see later, be used for open source developments themselves, or as well for smaller companies, smaller projects. So I will not, I would say, mostly talk about automotive grade development with thousands of developers. I'm coming more from the background now of industrial functional safety, and I will explain a few things later as well about that. So also really from this focus of what and how can smaller developers in open source communities do functional safety development without the need of all the commercial tooling. Just about me, my name is Christopher Zimmer. I'm working now at innotec. I'm a safety consultant there for 1.5 years now. And before that, I was more than 8.5 years assessor for functional safety at TÜV Süd, assessing many different things from operating systems, hypervisors, all the low-level stuff, the nice stuff. Doing also semiconductor IP assessments. So as long as it's still more software than hardware, I was involved there as well. Doing assessments there for ARM, Intel, NVIDIA, and so on for their silicons and IPs. For all different domains, be it automotive functional safety or industrial functional safety, typically for these kind of products, they aim to go for every standard. So that's why I was involved also in all the industries, in auto cell stacks, be it operating system targeting, industrial and automotive functional safety. Also giving trainings and so on. And now in my function as a consultant, I also want to develop now nice workflows and help the community in order to achieve their functional safety projects also on an open source side, also for the smaller companies. There are 3 points to what I want to talk about, and I think it's usual, like in the other talks. If you have any questions in any time, just interrupt and ask. First of all, very short, what are the challenges for safety compliance for the smaller, medium companies, and especially also open source communities? Possible solution, the life cycle with the open source tools that I want to present. And lastly, talking also about the topic on how to safely use them from classification and qualification aspect of these tools. I will not cover every tool. This is only just an hour. So there are many more details to discuss maybe, but to give this overview of how this can be done. Yeah, challenges for safety compliance. First of all, of course, the usual stuff. We have a lot of different standards coming from different domains, automotive, industrial. I will not talk about aviation and so on because I'm not familiar with the details of that, but for those domains I'm familiar. We have very different kind of software getting developed, be it the low-level embedded firmware in C, maybe application software, C, C++, or even function blocks that are getting used in these libraries. And then finally, really application software, limited variability languages, as the 61508 calls it. So the typical automotive, not automotive, sorry, the industrial side, the function block diagrams you see there, that's also programming. In the end, also safety related ones. So there's a lot of different types of software that need to be covered. For this toolchain, I would say this is something that can be applied to any kind of these developments. But of course, the more requirements there are, be it on the low-level development, and of course, the more tools and steps I need. And this is, of course, in this full picture I want us to show later on. When we talk about the differences between the industries, a lot of times it's the size of the industries, of the companies involved. In the industrial side of things, we a lot of times have companies really starting from 5 to 50 people in size. There are maybe 1 or 2 or 4 software engineers. There are a lot of mechanical and electrical engineers and so on. Whereas, of course, in automotive, we are talking a few thousand per company and so on. So, of course, this makes also a difference in when selecting the life cycle, the tool you want to use in it. Also, with the smaller companies comes that a lot of times the processes are also not that well defined, even if they are existing at all. Because if there are only 3 people, they will not have a full-fledged process environment they live in, because the 3 people always working together sit in the same room and that's it. That's their process. They talk to each other. So yeah, there needs to be a bit more, and we want to guide also via this toolchain really set up this workflow that they don't need now 200 process documents as well. It does not change how they actually work in the end, but to help them really formalizing the process they have and better documenting that down in the end in order to achieve then also safety development. We also have really the extreme when we talk about 13849. This is the machinery functional safety standard. In the first edition, there was not even, now in the second edition from 2023, we have it finally, but in the first edition, there was not even a requirement for a safety plan. It's not there. So there are different backgrounds when we talk about functional safety coming from the different domains. So what do we typically see when we come to the companies or help them? Yeah, in the best case, we have something like requirements are kept in Word and Excel, and somehow manually in the end, maybe a traceability between these is established. Maybe somebody has written a VBA macro to do that in a more easy way. Maybe it's just the Excel list. Maybe it's just a PowerPoint presentation, and that's the whole requirement and specification. Or at the final point, it's a napkin. Somebody has drawn something, and that's the product. These are the realities in these domains we're working in. So getting these different approaches into a better formalized way using open source tools, this is really the goal we want to achieve. Why as well? Money, of course, is also a driving factor for that. These smaller company sizes do not allow for buying in commercial tools. For all of these different steps in our V model from the functional safety standards, talking about one tool for requirement management, design tools, compilers, everything. In the end, we end up paying more for the tools as we pay the two developers that we have that are using them. That's economically not feasible for these companies. So also allowing these companies to work in functional safety requires them to use a lot of open source tooling. Same applies, of course, on the open source projects themselves. Of course, we have in a lot of cases that the commercial tools are available for free for open source projects and so on. So that's then a good way. But nevertheless, that's not always the case. So therefore, we want to reduce, of course, as much as possible the dependency on these commercial tools. Okay, so that's the introduction part on why we want to do that. Then what do I want to present here now? This is a possible life cycle, some demo preset life cycle, like you can say, for complete tool chain. It has proposals for different tools, making up the different activities, what can be used there. It has been used in practice. That's what we do with a lot of our customers when they don't have anything on their side to set exactly that environment up for them. But it's very different company by company. It's based on what type of projects are they doing, what type of controllers are they using. There are many different variables playing into the actual fine selection of the tools. Nevertheless, this is an overview. In some cases, you also do not have many choices, I have to say. And on the other side, the tools, I think, give an overview that, yes, it's absolutely possible to build this kind of a workflow. So finally, we arrive at the interesting point. So this is the overview diagram. So what kind of tools are we using in the different life cycle stages of the V model? One tool we are quite fixed on, I would say, and I will, of course, explain in detail why, is we are using Sphinx to manage all of the documentation. And documentation in that sense means everything coming from requirements down to the design, test case, integrating test results, doing the safety analysis, and in the end, that's what I want to express here with the output as PDF or HTML at the end, to have one single navigatable package of information. You can also present to an assessor, which I can say from experience makes life very easy as an assessor if you can navigate through all the evidences instead of having 17 different PDFs open and control everything through them according to requirement IDs, because you're working with the export only, not in the life systems of the customers. And even there, you have one tool for requirements, you have one tool for test cases, you have one tool for the design. So you're always jumping between tools, which is not always something that works greatly, I would say. So that's one of the reasons I will come later to the details for Sphinx. There's also some plugins I will talk a bit about. Sphinx needs, for example, then, and also on the right side, Sphinx test reports to integrate all of these things together. On the lower level, when we talk about the unit level specification, design, and so on, this can be done also as part of the source code. Then we use Doxygen and Breath to extract it and to bring it into Sphinx. I will come to all of the details just to give this first overview. Then we have finally the implemented source files. We have the static analysis. For example, CPP check can be used for the static analysis there. Then we do the dynamic testing framework, CPP test, or the Unity C-test framework, for example. Then there's the question where to execute them. Can be host-based, can be something in simulators like QEMO or provided by the vendors, or really on-target testing. Then, of course, getting the coverage, code coverage data, source code coverage data, using then built-in features like then gcorp and then gcorp-r to create reports from that, and so on, all of these different tools. And everything, of course, running in some form of an automation. So be it now just, so to speak, a Jenkins server executing these tasks, or being a more integrated solution like GitLab, GitHub, whatever, is of course something that we always want to have in the background, coordinating all of that stuff and orchestrating it. And finally, also for reviews, if you're using Jenkins, for example, then of course you will not have issues and whatever in that side. For that, we would use things like Garrett or Review Board. So this is the big picture. Now I want, of course, to give you a little bit more details on why and what kind of tools we selected on these different stages. And of course, also show you some demo of how it looks like finally in reality, not just the slides. In general, one main problem with the documentation, especially with the smaller companies, but also I would assume you know that from your own companies, maybe when you do function safety, it's time consuming to manage all the documentation. It's difficult also to get all the approvals, for example, the versioning of the documents. Then you have your code in Git, you have the documents in SharePoint, then you have the requirements somewhere else. And a lot of different tools getting used when they need to work together. So what we want here to really have is that the documentation is in itself consistent, and this is a build step in the end that can be checked, that you have automatic checks on that, if that is the case, before merging them, so that in the end, that when you have something merged on your main branch, that this is an approved state. It's clear, all the approvals have been done, the reviews have been done. There is no, when I want to release now, collecting the right version of the document from somebody's PC, and the underscore final in parentheses 2 final, now really final version of the document. Exactly, and then the 4 internals use the assessor version, please. So to avoid really that, to have always a consistent buildable documentation, and before merging anything in, we need to ensure again via the review process that is in place. We don't need to write the process down, it's enforced by the tooling in the end, to ensure really that we have this consistency automatically guaranteed really by the toolchain itself. We want to have then really everything integrated, from requirements to the test reports, to test reports from other sides, the analysis, the user documentation, and everything should be part of this one documentation package. Not, again, 3 different tools, 3 different generators, and we need then manually to build something from Word here and something include from PDF there. And then also, as I mentioned, giving this as one package to an assessor, clearly showing, okay, this is everything our project is made up of. We ensured via the configuration management, via Git, via SVN, that only these right versions ended up here. It's a really traceable, clear information for the assessor as well.
One question. Is it possible to trace requirements to code and back?
Yeah, absolutely, yes. So
Okay.
I will talk about in the unit level check.
And have you hooked it up to tests yet?
Yes, I have everything working as a demo as well, so I can show you there how the navigation is.
So I mean, all these tools shall be qualified, right?
This is the last chapter I want to talk about. Yeah, not to the
Not all need to be qualified, only all need to be classified, and the critical ones need to be qualified, or the critical
All
features.
need to be evaluated, classified,
Yes.
and then go
if
from there.
needed, qualified. Yeah.
Don't
And this is the third chapter I want to talk about, where I have a few examples of how this could be done for different tools. I will not talk about all of them because time is running, and but I will come to the topic. Yeah, one main thing which I think is really also important, keeping this information like design information, requirements, and so on, not only when we're talking about the software development, but also for other developments, where it's a bit more difficult, I would say, to do, but keeping that as close to the source as possible. Because honestly, what are engineers and developers doing? They are not looking into the nice web UI that takes 30 seconds to load for visiting a requirement and then clicking on the link, clicking on the next one and waiting 2 minutes again until the requirement management software decides to pull up that information. It's not getting used. If you,
Question on this.
Yeah.
Would you see, or do you experience that it really basically goes into the code level, or that the rendered documentation then later on created on the Sphinx documentation is also referred to? Because I mean, I personally have the tendency to stick even in the
the source.
in the source base.
Yes. So I would say both are possible. I personally, as a developer, would just stick to the source because I can directly navigate to the source. Or maybe it's just above the function is my specification. I can just scroll up above and can see it. But maybe for like diagrams and so on, more complex rows and so on, I maybe need to have a look into a rendered version as well. So I would say it's both of these aspects, but I would also stick first to the source.
Yeah, one question. If it is for the source, this is very nice. The question is it also, let's say, in the same repository or the same location? So you have, so you can have your packages, requirements, and source code, everything together?
Exactly. So you can do everything in one repo, but of course you could also use Git submodules and so on to, so to speak, separate out the specification. It's really up to you. You can mix and match like you want to do it. And I will talk later when we talk about unit level specification. You can absolutely have that directly included in the C file, for example, itself, and not in a separate file, but it's really up to the user how he wants to use it. Yeah, so in the end, we have the docs as code, requirements as code. Now we are at X as code because everything should be code in the end. Regardless which industry you're looking at, everything should be defined in the code. We want to have the same here as well to make things better manageable. We avoid, honestly, also the topic of vendor login. This is just plain text information in the repo. Yes, it's a specific format for Sphinx, but the information is still there. It's not a database I need to extract it from. I can. There's also a plain JSON file where everything lives in the end after the rendering process. So it makes me
some performance evaluation aspects, because there is some reason why we have also databases and not everything.
Exactly. So there are things like that, and we'll talk about in 2 slides what can be done there and how it can be integrated. So then the question, and I would assume, we as you mentioned this morning, we had already, or you had, I unfortunately was not able to visit yesterday, but the discussions about, or the information about strict.org getting used for that. There are other formats that can be used to do this kind of work. Why did we select Sphinx in our case? First of all, it's a quite established tooling. So it's getting used by the kernel already for documentation purposes. It's something that is, I would say, widely is maybe too much, but it's quite used already in many different projects. We have really nice HTML, PDF outputs. I would say from the syntax wise, restructured text, the format in which Sphinx input documents need to be written, is a middle ground in complexity. It's definitely not as simple as like an ASCII doc. That's by the nature of the functionality we want to implement in there. But it's okay, I would say, to learn. But of course, this is one of the points I have here on the next point as well, or the point after. There is, of course, like a skill gap when we talk about system level hardware side. Because an engineer, software developers will definitely be familiar with, or can be made familiar with restructured text in a few minutes to hours. But for a system developer, for a product manager, for a hardware engineer, that's a different story. And we want to have these requirements here in the same system as well, of course, to give a full picture when we talk about product development. So for that, others also have now this problem. So there is some movement. And last week there was the Sphinx Needs user days here in Munich, where this topic also was discussed heavily also in April this year. So there might be also some movement to bring in also some form of an UI visual tool to edit the requirements, not just the plain text format. Of course, in the end, it will be the plain text that's the one that's getting checked in. But to make editing and writing requirements easier for the ones that are not software developers. This is definitely some form of a gap for now. But I would say this is definitely not some point where we're saying, okay, no, then it's not usable. For the software side, it's completely usable. And some form of a syntax you always need to learn when talking about some formalized way of writing requirements. What's also important point is Pandoc can convert to and from RST. So existing documentation can be converted to RST syntax quite easily. Of course, it's not perfect if you convert just a docx Word file that a customer currently has to that. Of course, you need manual editing to clean that up, but you have all the base information there. So this is also a very important point. How can we reuse the information that's already existing at the companies and bring that into this restructured text format? And then the main advantage, I would say, for Sphinx has a very rich ecosystem in terms of plugins. There's a lot of extensibility built in and a lot of plugins available. And I will talk about a few of them that we then actually use. One example where this has been used, Sphinx, for also open source functional safety development is the tool side, not a product, embedded software component, but the Ferrocene Safe Rust toolchain. Uses Sphinx for all the safety documentation, doing the safety plan. All that is publicly available in their GitHub. Yeah. So you can take a look there. How they are using Sphinx. They are not using Sphinx needs and Sphinx test reports as we now use, but nevertheless, they're using Sphinx in order to generate all the safety documentation from their lifecycle as well. From the specification, the language specification of Rust, down to the tests and so on that are testing the compiler that the specification is adhered to. So this is a publicly available example on how such a workflow can look like. And honestly, that was also my starting point and why I wanted to discover this topic more, and gave them also was an input there. Hey, Sphinx is a nice tool that could be used for that. Sphinx needs. So this is the main plugin that we're then using. This extends the restructured text, as I said, is a bit more complicated. So you can have directives, and you can see the requirement directive here at the bottom. So we can define functionalities inside that language. And Sphinx needs provides the ability to manage needs objects and link them. These needs can be whatever you want. That's up to you. You have your project configuration file, and you define what type of needs do you have. For example, system requirements, software requirements, unit design, unit test results, all these things are some form of a need. And then you define the linkages that can exist between these type of needs. And all of them can then be accessed in the code and the RST files via these directives like the .rec, for example, for a requirement. Now, also since last week, in the newest versions, Sphinx needs 6 point whatever, it supports also schema validation. So now you can also define in a JSON file the schema that all of your project needs to adhere to, be it from naming, be it in conventions of what link types can exist between requirements and so on. So all what we currently have done with Python scripts afterwards, the fact that this is adhered to now, this is part really of Sphinx needs itself. All this validation, does a trace exist, how many, you can limit it, you can do arbitrary expressions over it, You can do local analysis of one individual need. You can do network analysis between the needs that are linked to it, and so on. So it's a very capable way of validating that your structure of your project is actually used correctly according to what you have defined in your configuration. You mentioned this topic earlier. Now, what about making this accessible easier as well, and so on? So there are extensions available to make life a bit easier in Visual Studio Code, to navigate easier, to jump directly to definitions, and for example, this topic of building the documentation. So this tooling from UseBlocks, for example, also provides a live preview functionality. Directly see the rendered or possible rendered out HTML of that without doing the full build of the whole project, because yes, it can get long. So there's one very big project, the S4 project from automotive, using exactly Sphinx and Sphinx needs. And they have in their basal build times, I would say 45 to 50 minutes or something around that. It was cut down from 75 to 40-ish minutes.
I mean, the thing is, it computes roughly 50 repositories.
Exactly, and there's a lot of information to pull in.
Everywhere in,
So yeah, a full build in very large projects can get longer. When we talk about the dimensions, we are talking typically about our industrial customers. This is not really a problem. This is like still in the low minutes to build the full documentation. But with the additional tooling, you can also have the live preview if you just want to correct some smaller mistake and whatever, and not to wait for the full build. And they also provided free for the open source non-commercial projects. So that's available as well. But nevertheless, otherwise, it's just source code.
Isn't there also that Sphinx that the UseBlocks people have certain commercial extensions which tend to have better performance?
This is why they get the live preview. Exactly. This is why they can do this live preview, because they're not using Python and Sphinx in the background to build this information. They are using their own Rust version of it, which again, when we talk later about qualification, is also some positive aspects, because now we have two completely differently developed tools doing the same job, linking these requirements, and checking traceability and so on. So yeah, can be an argument again, but we come to that later. So there are extensions available for that purpose, but again, you can absolutely do the smaller, I would say, projects, industrial side projects, and so on, for what we also doing with our customers in a lot of cases, without the need of the commercial tools. And they're not expensive and free for the open source side. As I mentioned earlier, we have some form of build automation server, automated build environment in the background. Everything lives under configuration control. We have then GitHub, GitLab, running your community edition, local instance, Jenkins, whatever you want. It doesn't matter. We provided some examples for that as well for GitLab and Jenkins. For GitHub, I have not done it yet, but it's not that different. Then, as I mentioned, maybe you need some additional tools that for doing the merging and review and approval process. In the case of Jenkins, again, for example, we don't have anything integrated in there. So for that, we would say we could use Garrett or Review Board as two open source tools again to do this work, especially Review Board, I would say, if you're talking more about the full product development, because it's better, I would say, for doing review of arbitrary kind of documents, whereas Garrett is, of course, a bit more focused, I would say, on source code. So if you then say, I don't know, I get a test report from an EMC test lab and want to integrate that, then I can with Review Board also do the review of this PDF, include that in the traceability chain, merge that in and approve it. Again, there's tooling available for all that. It's commonly used, widely used open source projects. Nothing where you need to rely on some niche, last updated 12 years ago tooling. It's all widely used, commonly used tools. Before now going to the next steps, I would like to show you two examples. This is here, and I can somehow get rid of that banner. I can't. Well, So there is one from the Sphinx Needs demo site. If you go to that, you can get a nice view on how this can look like in the end. This is based, as you can see, on an SPICE environment, so to speak. So with the different levels of, for example, the incoming requirements that we get. Where we want to develop an ADAS system, we need some lane keeping assistance, whatever. And it has incoming links from some higher, incoming links from the lower level requirements that are now refining this overall need, which is maybe marketing requirement or whatever. Again, this is really up to you how you define these levels. They set it up, so to speak, in a more SPICE way. But this is how then in the end the HTML information is rendered out. We have then the requirements on the next level, the incoming and outgoing links to that. You can define the system architecture design with Plant UML, for example. This is directly integrated. Also, needs can be identified inside the Plant UML diagrams. I don't think they have done it, no, this demo. But you can also define these needs inside of the Plant UML diagram. So you can also click inside of the diagrams and navigate and everything. So that's also all working. Deriving then down to the software requirements, deriving the software architecture, having that in the UML like definitions of the classes and so on, detailed design, all the usual. So, and you can see here also as well, they have extracted that from the source as well. You can go there as well to the source. I think in this case, it's a very easy source. But it,
Christopher, can you make it a little bit bigger?
yeah, sure. If I can.
Thank you.
Well, not too big, so yeah. So this is one example of how this information in the end can look like. Again, depends heavily on how you set it up. I also can show that on our side, what we have done here as an example project. So if I go there to the Sphinx documentation that is generated in the end, we have the same thing here. We have requirements on the software safety level, for example. It's maybe linking to something on the system level. You can import information from other sources in the usual formats, be it down to a CSV in the Word scenario or in DOORS formats and so on. You can connect to these kind of things with commercial tooling, not with the open source one, but for that one, you need to have some form of a JSON or CSV connection, or you write your own service. It can connect also, for example, to GitHub and so on. To gather information from there. So you can link to other sources outside as well. You have then, in this case here, this requirement. You can have some partial requirements of that requirement link here. There's then the small numbers in here that can be referenced later. So all the usual things you would expect from requirements management. There's also this nice preview thing you can add as an additional one where you can then directly see previews of where it links to instead of not just directly navigating to it, to just peek into what's referenced here. In our example, we set up then, okay, the architecture. We have just a small one component or two components. One is writing some data to an EEPROM, whatever, doesn't matter, just an example. This is our architectural view. And then we have the unit design. And we had it before, the question regarding where can this unit design be described, same repo, same file, and so on. In this case, we said, okay, we are doing that as part of the source file itself. The developers are already accustomed, I would say, to writing, for example, Oxygen documentation. So now we want, again, specification should come before we do the implementation in most cases. Of course, if it's then really starting out with the structure, for example, a specification document, then it's also easily done. And if you do that in a Oxygen format, then maybe the developers are already familiar with it, but you could do it also, as I mentioned, in a separate RST file and write it in the normal syntax. So this is exactly what I want to show here. The extraction can be done via Oxygen and Breath, for example. You could also use a more lightweight, I would say, plugin. Then instead of running a full Oxygen, you could use Sphinx code links, for example, which is again a plugin for Sphinx, which scans source files for links these requirements, but in this case, it's really just a pointer. So there's not a specification then contained in the source file. It's just a pointer towards where in the other specification documents this function is defined and detailed. In our case, for example, here we did the traceability on the unit design level by module name. This is the file name and the function name inside. And via that, then of course, this needs to be unique. Otherwise, it won't work, of course. But theirs is then the last level of where the traceability is established down to the source code. And I can show you that, of course, really in the code itself as well. This was the wrong one, of course. So if we go here and we have then here the source file, for example, then in this case, can make that maybe a bit bigger as well. Here in the end, the function to write some parameter list to an EEPROM, and really above that we have the RST. In this case, it's needs objects of the type specification. We have an ID. It implements this component and this software safety requirement. Short description. The UML, the planned UML code to write to have this diagram, and then the parameters and the return values. And from that, yeah, so.
Maybe a question related to the capability of RST.
Yeah.
So, for example, what if you need to have multiple multi-line fields? So what if you have to have not just statements, because your previous demonstration had statements, but usually there is also rationale and a comment, and they are, let's say, 3 multi-line fields. Do you ensure this separation at the level of the field?
These attributes that are mentioned here are completely freely defined.
Understood. But those are single line fields, because your RST directives, they support only, let's say, like those above, they are single line. You cannot do them multi-line. It's
the code here is multi-line. So
it is. But if there is a second field, right now this all belongs to the same field. So it's like your single, let's say,
description of the requirement.
Single tone statement. What if you need to have the second rationale for this markup?
I would include that as an attribute, honestly, then for this specification.
Even if it's multi-line.
Yeah.
Because that was the original reason why strict doc appeared. It was one of the limitations. And the second limitation here is that, let's say you need to have a single line field, but you want to have it in a way like an array of lists. For example, the SPDX snippet is not just one value, but you would have like a key value nested thing. And back then, a couple of years ago, it was really hard for me to implement this with these things directly. So I'm curious how you, let's say.
Honestly, for arrays, for example, I have not yet come to the point where I need it.
Okay, fine. Understood.
I'm not 100% sure whether this is now easier to do than compared to earlier, or it still would pose a difficulty to use it in that way.
Yeah, it's just the only point, actually, let's say the only reason and the main driver why the custom strict doc was created, because of these limitations, and some other formats they could also not handle this, let's say, variety of meta information that a typical requirement would have if you really want to be able to model every possible requirement.
Yeah.
So one question.
Yep.
This is like what I understood. Like this is in the same source code where you have implementation. It's manually written. Yeah. So like you first wrote it.
Exactly. This
so first
the V model will be presented to the assessor. We have written this block of text beforehand. This is the specification, and afterwards the developer wrote this function.
Exactly. And also it means that it's in the same C file where somebody wrote the unit test, like specific. Like sorry, I want the specification, like, but because it's like test has to have specification as well. And then like any time, it's a good thing that you can have at the same time, because the person who's reviewing it can see also the source code. If there is anything modified in the source code, it has to be modified the other one. But the problem, like sometimes it's like from the company's point of view, like it can be also separated. That's the question. Okay. Because like most of the time they don't want to ship this outside and keep it internal.
Of course.
And only ship the source code. So it can be also outside.
Absolutely. Yeah. This is just for convenience reasons, so to speak, to put it here in the same file. It can just be a separate RST file, just containing this code here as well. Of course, you would do it a bit differently, because then the params and return values you would need to define in here as well, compared to doing it by Doxygen here in one location. because of course we want to avoid writing things in multiple places. It's the same information, but otherwise it would be the same as the separate ASCII file. Okay, great. So that would be really for the specification side of things. Again, Sphinx needs on all of these levels. Now, if we continue further, static analysis. This is really a bit of a problematic topic when talking about open source tooling. There are not many open source tools for doing the static analysis in the way that our functional safety standards expect. We would, for example, in this case, here use CPP check to do the static analysis. Whatever the rule set, this is completely up to whatever industry you're working in and so on. So this can be a million of different things.
There's Clang ID.
Clang tidy is there, yeah. If you're using Clang as a chain as well. So if you're already in that world, then of course makes sense to continue on that side. If you're more on the GCC side, maybe then CPP check. I don't know. Depends again on the projects. But yeah, that's more or less it, I would say. CPP lint it's not really something I would say. C++ and more on the linting side, maybe on the Google style side, and not on the functional safety one. So this is a limitation. I would say there are not a lot of alternatives available. But I would say that with CPP check, this can absolutely work for the project.
So CPP check could be a replacement for clockwork, essentially.
For example, yeah.
Okay.
Because I mean, if you want, there is also of CPP check a certified version available. They have also, I think, a free certification, but there's also, of course, the open source community one. And again, there is not a difference in the tool itself.
Yeah, maybe to iterate on the Clang tidy, we actually use it with the GCC projects. You just need to bundle in the LVM distribution, and it works great, especially if you activate not just the default rules, but let's say more items. And the second thing, again, not to endorse, but CPP check is great. And so this commercial version is quite cheap, so it's very accessible. And
Exactly,
on
so
top,
still accessible compared to others. And you do not pay by lines of code analyzed and stuff like that.
exactly. So it's a great tool from our experience.
Yeah, but we have experiences with LLVM, Clang, and GCC. So GCC, both are C++ compilers, but our experience was that GCC accepts C++ code, which was not C++ code of our judgments. So it just guessed what could be meant and did something which was not written in the standard, while Clang just refuses to do this.
You're welcome to see.
Yeah, but this just you were lucky in your project that this well, with GCC working, it did. Maybe you had good programming guidelines, MISA compliant, whatever. Then it should work better than if you do any other wild code.
Yeah, again, not that much available there on that side. I mean, you already also know the integrations and how this works. Of course, then you have your warnings, you can integrate them. It's just like all the other commercial tools as well, and integratable in the open source side in Jenkins, and you get the warnings and everything. All the violations I have purposely built up into this project, of course, to show that it's working. So that's the static analysis side. Next step is, of course, dynamic testing. Now, before that, doing the compilation to get to a dynamic testing. Compiler, again, it's very, very project dependent. So sometimes you have, of course, microcontroller vendors forcing you to use a specific tooling from their side because that's the only compiler that can compile for that target. I mean, there are still some of these targets available. Sometimes as a company, you already have that tooling from your previous projects. Your developers are familiar with some commercial tooling, whatever, or of course, then with an open source based GCC or LLVM based development flow. So sometimes you don't want to change this topic because your developers have experience in that and you already paid for the tools maybe. So then you continue on using them. Sometimes you also need different compilers. If you talk about unit integration level testing, not always is this done with the target architecture or on target. So you do this on the host, maybe on x86. So then maybe you need a different compiler for that. And I will talk to that topic later on. Why maybe it's better to use a single compiler. In the end, it is really heavily dependent on the type of project. We can't make a suggestion now. Depends. but there are open source tools available. And if you look also on safety certified compilers, yes, there are maybe 2 or 3 compilers that are own in-house developed compilers. Everything else is just GCC, LLVM, and then something on top, which is testing. But the compiler itself is also the open source one. One topic also, of course, when talking about compilers always, or any kind of these tools, considering what kind of libraries are delivered together with it, and are you really using them or really want to use them? So this is always this topic. This is not tool. This is then embedded software, needs to be handled differently. But in our case, for example, for all these industrial projects, so on, we compile with no stdlib, no standard library, no other libraries included. We don't need them, but other projects might require them. But then again, this is an additional topic, but this is not something I want to cover now. Yeah, dynamic testing frameworks then, executing, writing tests. Again,
let me just comment on this. So typically, the compiler includes libraries, which are which of course you said it correctly, embedded software at the end. But safety differentiates between embedded software that you just write on your own software, and software you are reusing, where the risk is shared. So if all people use the same glibc, then the risk is shared among many people, and therefore the qualification or safety requirements are less critical. So we see there are 3 classes of risks. So software, which is newly developed. It's a really pre-existing software or libraries, and then the tools. So these are 3 classes. So just
and to always distinguish between them.
Yes, yes.
That's really
important job for this. This is like a risk class, like is it A, B, C, or D? So you cannot just say, hey, so you have these very popular is it A, B, C, D, but you also have this kind of risk class. And it's in all safety standards the same way.
Yeah. Yeah.
But this is only automotive. This is not airborne. Avionics
No,
is not allowed.
In the IEC 61508, it's the same. So you have it's called pre-existing software, and the chapter 812 in ISO is replaced there with the so-called root 3S, which is for qualified pre-existing software. So
but the problem in a dull IA software, anyhow, you have to show all source code, even in the libraries, and you have also to show that which parts of the library you have executed and so on. So this is so you also have to certify the libraries.
Yeah, dull A is different.
Aviation is different. Yeah, on the framework side, dynamic testing side, there are multiple frameworks also for the embedded side. CPPU test gets used often, especially from the application level developers doing C++ stuff. I also want to throw in the Unity test framework for C, which is a very, very small one, just for files. So it's easily portable to also do, for example, then on target testing. In the end, they output JUnit XML. So that's digestible then again by any kind of continuous integration toolchain again. So that's the only important point in the end. We want to be able to integrate it in the automation flow, both open source, everything there in order to write your tests. No worries on that side. Test environment, it gets again a bit difficult, depends on the controller what you have available. Maybe the controller vendor provides a simulator emulator, so you can run on-target code also on your host to speed up testing. Maybe you can use Limo to do an emulation of, for example, ARM, or you go for the on-target testing. Why would you go for the on-target testing? And I have it here as well. The on-target testing, when measuring, for example, coverages and so on, they will later on provide a nice additional evidence for that the compiler has done the right thing. If I just use one compiler, one backend, one architecture, and testing that binary event, then I'm pretty sure that the compiler has not done something strange.
I just wanted to mention the Google test framework, GTest.
GTest, yeah.
Which I missed somehow on your list, which is
definitely also something
open source.
As I mentioned, during this dynamic testing, we need to collect code coverage data according to the safety standards. Again, if you have a commercial IDE already, that typically includes also facilities to do that, for example, in the target testing as well. Yeah.
So like the coverage ready to coverage. Now it comes to like GCC and LLVM. How does this they behave completely different for coverage. They don't like how they collect the coverage is completely different.
Mhm.
And what's your experience? Like which one you used and because you can have a
Depends.
yeah. So you could have a different number of coverage numbers from same to number of tests from everything from GC. If you use LLVM based, it's a different one because they use different, and GCC use different one.
So again, this is then again depending on the project. So if you're doing host-based one and you use GCC, you will use GCOV and get coverage from there typically. If you use an LLVM-based one, you get it from there. I would again strongly suggest to go for really target testing in that sense, because then it will eliminate the need for in the end to find additional compiler qualifications. Because if I'm testing everything the compiler has outputted via the code coverage can show during on target running.
Yeah, but you're still getting it result from there.
You get that information via your JTAGers.
Yeah, but I'm just saying, even in the target-based testing, we had some projects we are using the target-based, and we used same like both LLVM.
And you're not for the target testing, you're not using the GCOV or GCC and LLVM integrated coverage metrics or generators. For that one, I would strongly suggest this is again the second point where open source is a bit lacking. All the big JTAG probes can collect live coverage without modifying the binary. Yes, you have problems regarding MCDC because that's not visible on that level anymore. Yes, that's true. So SOD, one topic. But for everything else, when we talk about function and branch coverage and statement coverage, you can collect that live information without instrumentation. You get really the results from running the binary. And this would be my preferred approach.
Yeah, well, two comments. So you're really right. So the compiler integrations of LLVM and GCOV are closer. So typically, for example, if the compiler does some optimization, the coverage just disappears, and you will never see whether you covered it or not, which is somehow dangerous as well. But let me come also to your point regarding coverage. Compiler qualification is not necessary anymore. So if you measure code coverage on the source code level, then the compiler can do a lot of things. So we have seen a compiler expanding code by the factor of 4. So from 100% MCDC coverage, you had 20% object code coverage. But if you really go for object code coverage measurement, then have fun. Then have fun. But then you don't need to qualify the compiler. And if you do optimization, you will have more fun. So I wouldn't really recommend to not qualify a compiler.
Honestly, it's not the only argument, but it's one strong argument why it works. Of course, aviation has the different approach of the object code coverage, so therefore we don't have the problem.
And a final remark, even so since a year or something, LLVM and GCOV have also MCDC support. And well, we can qualify those. We have qubits for that as well. So no need to buy commercial tools.
Exactly. So we now have all the possibilities in these tools when doing host-based testing as well, but also on target with more difficulties, and then also selecting which one to use. But we could also use the external observation only by the trace and JTAGers. So there are many different ways to get this information. But yeah, it depends a bit. Not everything is possible with full open source. For the JTAGers, not aware of a
They are not
source JTAG
open source, which is like the coverage as well. They are not.
Exactly, yeah. But yeah, in a lot of cases in the companies, you have already a commercial JTAGer from some of these companies that can do it.
So it's also possible to include vector cast in your toolchain.
Absolutely, yeah.
Okay.
Yeah, and this last step of including now test reports, results from different test levels, and so on is, you can imagine an additional plugin from Sphinx needs, or for Sphinx test reports. This can link JUnit XMLs, also linked in directly via specific rules you can define to the correct unit specification, for example, and so on. Or you can import a custom JSON test result file coming now from maybe an integration test, maybe a manual test, whatever kind of other systems there might be, in order to have these also integrated as part of the Sphinx complete documentation package. So this is the last plugin that's getting used there.
We have 3 more minutes.
Exactly. 3 more minutes to talk about all the classification and qualification aspects. So I'm keeping it very short, but I mean, you get the slides afterwards to get more details, and we discussed a few points already. I will skip over why we're doing that parts. I will go directly here. We mentioned this topic, classifying the tools first. And for example, for Sphinx needs and all of these Sphinx-based tools, you can take a look. We are currently working on that. This is publicly visible in an open source repo. So if you go there to Sphinx Safety, and you get all the information of, and I will talk how this looks like. And of course, there is again a closed source use case as well. Time needs to be paid for this topic of then linking all the test cases, whatever. But you don't need to buy that in. You can start with the open source part as well and then do this last step yourself. Again, I will talk about some details. So it starts off with defining the use cases, of course. What do we want to do with Sphinx? What kind of tools Sphinx needs, Sphinx test reports, the code links, and so on, which plugins are in scope of that classification. And of course, as you would imagine, this classification and analysis is done also in a Sphinx project. Otherwise, of course, it would be strange to not generate this documentation with Sphinx. So we're also using Sphinx needs objects to model that. That's again all freely available. You do the analysis, you analyze the tool features, use cases, the features that are used in order to realize that use case, and then we have the false regarding that feature. And then we are linking either restrictions, don't use that because it's unsafe to use for a safety project, or yes, there's a test case, or there's an additional check in another tooling that can avoid this kind of problem. That's available in there, and I will just go here. This whole approach of how we do this classification and qualification is completely written out there, how we do it. You can take a look also on Ferrocene, for example. There's also completely described this approach on the qualification of the compiler. The same applies here, very similar. In this case, you can really use also this Sphinx project as a template for your own tool qualifications that you're doing. You can do the same thing, so to speak, for other tools as well. This would be the base structure on doing the analysis and linking evidences. So this can then be extended also to other tools. And as I said, all the parts regarding analysis, classification, and restrictions are part of the open source repo, also for the ESCO project. I mentioned the compiler as one of the examples. Again, we don't want to discuss further on that aspect. Strong evidence if you use on target because you're just compiling once your test binary and you're testing everything of that. This gives a very strong argument, one argument. And I'm not, it's better.
Then we will stop sharing, we stop recording.